Our next set of videos are going to use some of the same techniques that we just used, but they're going to take a different turn for what we're headed for. Now remember earlier, whenever we said solve, what we're guaranteed is an equal sign. Remember, even when it's talking about equations, know that there's going to be an equal sign. And remember, know that what we're looking for, the example we saw earlier, was what we're looking for. The reason that x equals 3 is because we always look for what number when we plug it in makes it work. 2 times 3 is 6, plus 1 is 7. Now, techniques that we have for solving prior, inverse operations. If we wanted to get rid of a plus 1, the opposite of plus is minus. If I have plus 1 minus 1, it cancels. What I do to one side, I do to the other. That gets me a 6. And again, this one we're talking about equations. This is what we do on each side. When we say each side, it's of an equal sign. 2 times x, remember that 2x means a coefficient, multiplication. Multiply and divide, cancel each other out. What I do to one side, do to the other. X equals 3. There's where that 3 comes from. That's if we have an x to the first power and all we need are a few inverse operations and we can cancel things out. Well, we also have, what if we had x squared equals 9? One of the inverse operations we have of a square is if we take a square root. And we'll spend a whole chapter talking about square roots. Square root and a square cancel each other out. That is what the square root is, the inverse operation of the square. What I do to one side, I do to the other. But now, if I were to ask you what's the square root of 9, I'm actually going to get two answers, x equals 3 and x equals negative 3. And here's why. When I plug it in, remember that ultimately I want to look for what I plug in. What's 3 squared? 3 squared is 9. But what about if I plug in negative 3? Go back to that very first few set of videos. If I had a negative 3 squared, negative 3 times negative 3, negative times a negative is a positive. But also, whenever I have a negative base and an even exponent, I still get that positive 9 in this case. Remember, those cancel out in those pairs.